Some great news, as you can see. Your vehicle passed most of its inspection. I do have a little bit of bad news. Your four-wheel alignment was actually out on your vehicle, and so what we'd like to do is get your alignment done today. Would that be something you'd like to take care of?
Sure. Yeah, let's do it today.
Wonderful. I really appreciate it. It'll be for your benefit. Thank you very much.
Of course. Thank you.
Alrighty. Hello, I'm Thomas Settle. Welcome to our new sales training series. The purpose of this is to provide you tips for your product presentations. Part 1 will cover Road Force Touch. To begin our demonstration, the first thing that we need to do is decide the type of weight and the placement of the weight. So what I like to do is, I like to start at the very top of the screen. So the very first thing I'm going to do is select the weight that we're going to place. From there, I'm simply going to drop the hood, and I'm going to allow the balancer to do its job. So now at this point, I can point out to the customer that we've actually got to measure the rim run out. Now you can see I can just cancel right out of that, and I can go ahead and apply my weight and come back to that screen. Because again, what we'd like to do is just run through the process of all the features and benefits of our balancer. Now as you can see, as the weight that it called for came up, I've already got the weight set. So now I can simply apply the weight so we can show the speed at which we can balance. So I'm going to simply apply this weight. And at this point, if there's any questions that come up to the customer, I can address those customers prior to the next phase in our demonstration process. Now there's times where the customer may call for what is smart weight, and this question comes up quite a bit. So there's a real simple explanation, and what we want to do is we want to first get him to understand that we have static and we have dynamic or couple, which is that wobble. So now we can simplify the process of explaining to them that we have hop and we have wobble. Well, as we know, the customer's largest complaint and feel when they're driving in the car is that hop, not the wobble. So now what we can do is we can simply show them that with the hop and the wobble, our smart weight technology is going to look at those two effects on the vehicle separately. And now by looking at those separately, it will actually take into consideration that we can use less weight in the process. And we'll be able to demonstrate that. So now what we can do is we can simply show them that it did call for 1 ounce of weight, but what I'm going to do is I'm going to simply come into our smart weight feature and disable the smart weight. And as soon as I disable smart weight, now I have the benefit of showing that customer that residual weight that was left over for the couple forces that a customer will never feel. And now by looking at the screen here with residual, I simply can hit my start button. I can show that now on the inside plane, we're calling for 3/4 of an ounce. Once I hit start again, I can now show that the customer is looking for a 1/2 ounce of residual. So now those two forces being opposite and away from each other are counteracting and are pointless to be putting on in the balance. So now I've saved that customer 1¼ ounces. So at this point now, we can move on from our smart weight technology. So we'll simply turn that back on, and now we can address what we saw earlier. So at the very beginning of our demonstration, we had a warning that came up that said that we had excessive road force. So now we can demonstrate the process of correcting this road force, if possible, with our customer. So we're simply going to push the road force button, then we're going to hit our force match. Once we hit our force match, now we're going to go through the procedure of actually checking for the high spot and the low spot by doing a rim run out. Now at this point, you can see I still want to maintain my distance from the screen so I can allow that customer the view of what's going on. And now from this point, you can see that we have what it's going to take to actually solve this problem. Now what we want to do is we want to chalk the high spot and the low spot of this assembly so that we can take it over to our balancer, whether it be our 3715, our Auto 34, or our Revolution, and rotate these tires so that they can match perfectly. So now what we want to do is we want to set the tire mark. We're going to hit our start button. And we're going to come over and we're going to grab that rim run out chalk mark. Now from here, we're going to go ahead and look and see if it's actually going to be feasible to do this. Now, as you can see with this assembly, it's excessive to actually fix this. And again, this is just assembly predicted. So now at this point, we can express to the customer the importance of actually doing our road force measurement, and we can see that during the predictability, we can actually solve this problem. So now that might be the need to work with the customer on either a new rim or a new tire. So here what we're going to do is simply go back to balance. And again, as you can see, I've walked through the process. So now what I want to do is continue on with the customer and show them the other benefits that we provide with our road force touch. So now in the beginning, you saw that I had a pre-mounted assembly. But there are times when our technicians, as they mount up a wheel assembly, they're not exactly sure which wheel and collet combination go together. So what we do now with our latest software is have the ability to come in here and we can select our vehicle, so we select the right collet. So here I'm just going to select a Chevy Malibu, and as I pull that up now, you're going to be able to see that it's going to call for a bullseye collet, a yellow collet. So now that we know we have precise measurement and that we're utilizing the right collet. So from here, we can add on to the benefits of what we provide with our road force. So now as we start to wrap up our demonstration, we want to express the importance of our newest straight track feature. Now, to save time during this demonstration, what we're going to do is go ahead and pull up some of the sample data. So I'm just going to simply hit More and then go into Show Example, hit OK, and now all our sample data will be generated. Once this sample data is generated, we're going to get a little exclamation point. What that little exclamation point is going to allow us to do is discuss the importance of our Transaver feature, which this is going to allow us to talk to him about the size and diameter of tires. And as you can see through what we call tire stack, you're going to see we have a tire assembly that's 26.7, 27.4, 26.7, and then 26.7. Now there's a couple of things that we can do by seeing that. Number one, we can see if that there may be another technician that came in the middle of our work, which is okay because we can simply just run down to where I happen to see another 26.7 wheel and set that position. So I'll simply bring my labels down. Or simply what I can do now is I can identify to the customer that one of their tires is out of diameter. So now to ensure that I know which one of those tires is mine, or if it came from another assembly, I can even touch for extra info on that wheel assembly, and I can look at the characteristics of the balance on that. So now we can see with this 27.4 that it called for a 1 inch and a 3/4 ounce from the inner and outer planes. So now all I have to simply do is come to the tire assembly. I can look at exactly the weight that was placed on this balancer, and I can see if that's my assembly. And of course, we know we only placed a 1 ounce on this assembly, so for this sake of demonstration, we know that is not our tire. So at this point, we simply just close that up because now we've identified that that isn't our tire assembly. So the last phase of our straight track feature is now what we want to do is we want to discuss the benefits of straight track, because there's times where advisors are doing their due diligence and they're talking to the customer who came in for a simple oil change about rotating their tires. So now the benefits of straight track really come into play here, because traditionally now what the technicians will do during a tire rotation is they'll either move them from front to back or they'll go side to side. Well, you know, traditionally we could bring a car in that had no net pull, and we simply can do that side to side, and now we've induced a pull condition. So the simple fix before was about a 3 to 4 hour intensive procedure where we would have to take the car up on the rack and we'd have to rotate those tires, take it out on a road test, see if that pull condition was there, and if it still was, we would have to bring that car back on the rack and do another rotation. But simply all we have to do with the straight track feature, we come up here and say, listen, we want least amount of pull, the tires will set, and now we've actually gone through the process of ensuring that when we rotate those tires, we're in the proper configuration for that customer. So at this point, we've completed our straight track demonstration. Now we can simply show the customer that, again, you can see that we've got the make, model, and year of this vehicle. But of course now we need to do a check spin. So all we have to do is simply let the balancer do its job by dropping the hood and doing our validation check. We've allowed ourselves to answer any questions that they may have through the demonstration process. This simple point now, it's time to close the sale.